Hello, Calc students. Today, this tutorial is going to be going over 1.3, which is the exponential functions. And again, this is all things and material that you have reviewed before in your prior math experience in high school. So here is the class notes. It's in OneNote. I'm going to follow these, and I'm going to keep my videos relatively short, little tutorials, so that you can always go back to them and just find exactly what you're looking for, and I'll link them in our notes after I'm done. Okay, let's start with our exponential rules. If I have a to the x times a to the y, of course that's going to be the addition of our exponents. If I had y to the 8th times y to the 4th, that is going to be y to the 12th. We are 8 y's are on this side, 4 y's on the other side, and you add them all up, and you're going to get y to the 12th. If I had division, this is going to be the subtraction of the exponents. So if I had y to the 12th divided by y to the 8th, there would be 12 y's on top, 8 y's on bottom, cancel them out, and you're left with y to the 4th. So you're subtracting the exponents. Here's power to a power. If I had, let's see here, y squared raised to the 4th, you get y to the 8th back. Oh, excuse me. Let me put that was my example. Let me write down the rule. The rule would be ax times y. And the reason why it is y squared raised to the 4th, power to a power, is multiplication, because it's really y squared times y squared times y squared times y squared, thus y to the 8th. The next one, if I have ax times b to the x, the same exponent, then I can group them together and raise it to that exponent. So if I had 2 to the 5th times 3 to the 5th, I could write that as 2 times 3 raised to the 5th, or 6 to the 5th. The next one, if I have a fraction raised to the exponent, you could split that up as a to the x, b to the x. So if I had 2/3 raised to the 5th, you can write that as 2 to the 5th over 3 to the 5th. Okay, let's go into our definition of exponential functions. If I have an exponential function, then that means it's going to follow this model right here, this y equals a to the x, where the exponent is the variable. That is what's changing. You have a base number a, and a has to be a positive real number, and it cannot be 1. So if I had an example, y equals 3 to the x, that's exponential because the exponent is the variable, and 3 is a positive, and it's not a 1. Well, what happens if 3 was a 1? If I said y equals 1 to the x, well, no matter what you put in for x, you're always going to get 1 back. So it's a constant, that's linear, that's not exponential. It's not going to have that growth or that decay or that rapid increase or rapid decrease. Also, if I have 0 to the x, then that would also be a constant 0, and that's not going to be your definition of an exponential function. So here I have 2 examples, and I must have deleted the one by accident. The second one was supposed to be this, 2 to the negative x. Okay, so the first one is 2 to the x, and let's go ahead and graph this. If I put a 0 in there, 2 to the 0 is 1. Anything to the 0 power is 1. If I plug a 1 in, I get 2. If I plug a 2 in, I get 4. And if I were to reverse it, if I put a negative 1 in, what is 2 to the negative 1? That's a good review. 2 to the negative first power. If you guys remember, negative exponents means you take that number and you send it to the bottom. And that's going to be a 1/2. So, and it's going to be negative 1/4. And you're going to get this curve back right here. Okay, well, if I graph the next one, 2 to the negative x, if I plug a 0 in, you get 2 to the 0, which is 1. If I plug a 1 in, I'm going to get 2 to the negative 1. If I plug a 1 in, it's 2 to the negative first, and again, that's your 1/2. Where am I at here? 1 and 1/2. If I plug a 2 in there, it's going to be a 1/4. Now, if I put in a negative 1, if I substitute a negative 1, and then you're going to get your 2 negatives, I'll put googe there, and you're going to get a 2 back. So Negative 1 is going to give you a 2. If you plug a negative 2 in, you're going to get 2 to the second, which is a 4, and you're going to get a decreasing exponential function like so. Okay, just to clarify, 2 to the negative x, you can use some of your exponent rules, and you can write that as 2 to the negative first times x. So you could split that negative 1 and the x up, and then you can rewrite that. This 2 to the negative first is a 1/2 raised to the x. And this is your decreasing. It's 1/2 raised to the x. So if I had 3 to the negative x, that is also 1/3 raised to the x. Okay, I'm going to stop this video here, and I'm going to continue with the next tutorial with definition of growth and decay.